Okay, so this is the ODE that we have for this problem. So now I will explain the relation between this equation. Okay, so this is actually the mathematical representation of the problem. So now I will relate with its physical meaning. Okay, so general equation. Okay, this I've already mentioned. So um, if you refer to the equation, okay, we've already familiar with, for example, the first two equation here. Okay, before this we familiar. We have the right hand side is homogeneous equation because right hand side is 0. For the last two equation here, we have the right hand side are non-zero, so mathematically it is non-homogeneous equation. Okay, so physically, okay, for this case, for the homogeneous equation, if we refer to this equation, the right hand side term here comes from the external forces. Okay, so Ft is the external force or external vibration. So physically means that there is no vibration involved. Okay, or no external force. Same with here. Okay, because the right hand side is 0, so no vibration involved, or we say no external forces. Okay, but for the last two equation here, there appear the mathematically we say this is non-homogeneous equation. Physical meaning here is this is the case where there appear the external forces or external vibration. Okay, so what is mentioned similar with what is mentioned in the green box here, free vibration. Okay, the same as the same meaning as the no vibration. Okay, free vibration. But for the case there appear the force, external force, or there appear the vibration, then we mention the problem as force vibration. Okay, the problem with force vibration. Okay, so that is types of vibration. What else we can see in this green box is we have undamped and also damped. Okay, so the first problem here is no damping. Similar with the third one here, also no damping. Okay, this is related with what I explained earlier. If you see in this equation, there does not appear the term y prime. Okay, so in my previous explanation, the y prime term actually comes from the one that I said it is the dashpot. Okay, so actually the dashpot, example for dashpot is such as the shock absorber. Okay, it will damp the vibration. Okay, so when this term not appear means that in the whole problem here there is no distinct. Okay, so we don't have the damper. Some cases we call this as damper. Okay, so there is no this term. So in the equation, the total force only consists of forces by the spring and also the external forces. Okay, so the case no damping, the first one and also the third one. Okay, so we call it as undamped. Usually if you refer to some books, that problem is referred as undamped problem. Okay, while the second equation and the last equation, okay, the term y prime here appear, or if we refer to the original problem, there appear the, the one that I said, dashpot or damper. Okay, so this is named as the problem with damping. Okay, or damp problem, same with the last one. Okay, so in relation with what we've already learned in this course. Okay, we have the homogeneous equation, we have the non-homogeneous equation. So the equation here is in terms of y and t. Y is the position. So if we solve this equation, we're able to obtain y. Okay, so the general solution is okay. So if we do as usual, we solve the ODE, the second order ODE. We're able to get the expression for the position y equal to some function containing t. Okay, so here without the condition, we're able to get the general solution. But if we have the condition, okay, it can be initial condition, it can be boundary condition as well. For example, we have y at 0.0. Okay, for second order case, there must be two conditions to get its particular solution. Okay, let's say we have two conditions, y0 equal to alpha. Physical meaning is initial displacement. Okay, because y is the position, okay, or displacement. So at t0, okay, or at the beginning, this is its original position. And for the second condition here, y prime equal to any value, for example v, this is also called as the initial velocity. Okay, I already explained earlier, if y is the position or displacement, then y prime is dy dt, means it is the velocity. So this case is the velocity at time 0. So upward negative sign. Okay, so this is about the negative and positive sign. So if negative sign is upward, positive sign is downward. I think this one is for the case vertical spring only. Okay, we have downward and upward. Downward, the mass goes downward is positive sign. The mass goes upward is negative sign. In this case, if the spring like this, then we can define on our own, okay, whether we use it is stretch or compress. Okay, if we consider that positive, then this way must be negative.